This video will explain how to use a micrometer. I'm going to start covering general use, which will apply to any micrometer, whether analog, digital, metric, or inch, and later dive into details of reading an analog one, including its vernier scale. By the way, mic is shorthand for micrometer, and you'll hear me mainly call it that going forward. To start off, this tool is used to measure extremely precise values. Whereas you might use a caliper to measure thousandths of an inch, a micrometer can measure to 10,000ths of an inch, or 4 places to the right of the decimal. A 10,000th of an inch is over 100 times smaller than a human hair. And I mentioned this at the start because it's very easy to mess up measurements that are this precise. Just twisting too hard on the mic can affect the reading. When I lightly close the mic on the pin, it reads exactly 0.2499 inches. But without much effort, I can twist a little harder, and now it reads 0.2497 inches, 2/10,000ths of an inch smaller. To prevent how hard you twist from impacting measurements, most mics have a ratchet or friction thimble. Notice as I continue to twist, the part of the thimble with the numbers stops moving, but the grip keeps turning, and you can hear some clicking. This helps me apply a consistent force. It's like a built-in clutch that ensures the same clamping force gets used every time. These distances are so small that even dust or temperature changes can matter. This is why it's important to make sure the measurement faces are clean before you take a measurement, and also that the mic still reads exactly 0. To clean a mic, lightly close it on a piece of paper and pull the paper out. Mics that measure larger distances generally don't close all the way down, so you can use a lint-free wipe with some alcohol instead of pulling out a piece of paper. Now that it's clean, I need to check the 0. I close it all the way, twisting the thimble about a half turn after the numbers stop, and make sure it reads exactly 0. On an analog mic, this means the 0 on the thimble should line up perfectly with the central line on the sleeve. If it's not 0, you can adjust an analog one with the adjustment wrench, or on a digital mic, just hit the 0 button. Once you've ensured the faces are clean and it reads 0, you're ready to measure. I hold it with my pinky or ring finger in the frame while twisting the thimble with my thumb. This helps make sure you're not putting any twisting force on a part you're measuring. Again, I spin the thimble about a half turn past where the numbers stop. This helps ensure you apply the same force you applied when you checked the 0. Now I lock the spindle with the spindle clamp to make sure it doesn't move while I read the measurement. One thing you'll want to do if measuring a larger round part is sweep the mic to make sure you find the absolute biggest spot on the diameter. If you're just a little bit off, it could make a big difference in the reading. And one more comment about measuring so precisely. Handle the mic very gently. Even a small drop could impact its accuracy. When finished, open the faces a little bit before putting it away. This keeps any internal forces from building if the temperatures change while it's stored. Here's a quick review of what we've covered so far. Always clean the faces and check the 0 before using. Apply a consistent torque each time. Holding the mic by the frame and using one with a ratchet will help. Sweep around things to find the largest spot. Handle the mic gently, and store it a little bit open. If you want some help remembering all that, we have a training app that includes this video, along with periodic reinforcement questions. You can find out more at our website, reimagine.training,